Hey friends, we are back. It's dotnetConf, and we're going to have a day of community presentations, and we're going to kick it off right now with Andrea Geita, who is calling in via Skype from Denmark. Are you there?
I am here.
Hey, and she is going to talk about building the GitHub extension for Visual Studio. So I'm going to control the screen here and get out of your way as you start presenting. Thanks so much for joining with us today.
Awesome. Thanks for the intro. Hi, everybody. Let's talk. Okay. Can you hear me? Neat. Okay. So you can see my screen? Awesome. So hi, everybody. We're going to talk about GitHub for Visual Studio. My name is Andrea Gaita. As Scott said, I am the team lead on the editor tools team at GitHub. And what is GitHub for Visual Studio? GitHub for Visual Studio is an extension that lives mostly in Team Explorer and handles GitHub authentication and credentials for you, basically makes Git work in Visual Studio. It also provides some other features like cloning repos and creating them and linking code and opening code in GitHub so you can quickly share what you're working on with other people. And we are also trying to push new features like gist support, basically directly from Visual Studio, and pull request management, so you can manage your work directly from Visual Studio without having to leave it. For those of you who are not familiar with Team Explorer is basically the little area, a little pane that sits right next to Solution Explorer that gives you source control and collaboration. And Git or other source control that it supports. It's shipped as an extension, even though it's shipped within the box in Visual Studio. It gives you source control management and gives us services for querying what Visual Studio is currently open at the moment with Git, and allows us to clone and do other things. So the GitHub extension for Visual Studio started in December 12, 2014, when Phil Hack pushed the little first commit to get the party started. And I started working at GitHub in January 2015. So I was hired just to do this project. Hopefully they don't fire me when it's done. Anyways, we had 4 months, 3.5 months, 4 months to ship because we knew that we wanted to ship in April 30, which was build of 2015. And we had a collaboration with Microsoft to do this project. So we coordinated with them for this. So the coordination didn't stop with just aligning release dates. We actually worked closely with Microsoft and the Visual Studio team to get into Team Explorer team, especially to get us APIs that we could use to have Git information on the GitHub specific bits. The design and the UI, because we're integrated in Explorer, and also because there's a lot of performance concerns and dependencies that we had to be careful about. So our approach to make this work in 4 months was to basically start by making an infrastructure that automated everything as much as possible, which means setting up CI servers, build scripts that matched exactly what Visual Studio was building, so that anyone could do releases or builds whenever they needed without having to rely on local configurations, and being able to quickly validate and run tests every time someone opens a pull request or does a commit on the project. We also had to be very careful how we architectured the project, making sure that we had we split interfaces and implementations because we had a lot of performance issues, not performance issues, but concerns that because we were in Team Explorer, that everything that we loaded was an extra load on the Visual Studio startup time and memory and performance impact. So we had to be very careful about what we were loading and how and when we were loading it. So making sure that everything was properly split up, so we only loaded what was needed. And also because most of the stuff is myth, which means that we needed to be very careful about exporting interfaces and how to load. From the start, we wanted to open source the code. This was a thing that we had planned right from the start. Documentation, swear words on the code, all of these things we had to be careful every time we pushed code, how it would look when we open source and what we had to do if we had to make changes. Since it was me and Phil on the project, we basically split tasks. Phil took on the UI because he was already familiar with GitHub for Windows, GitHub for desktop code, and we took advantage of a lot of code that was written already for GitHub for desktop. So he took on that side. And I took on the Visual Studio and Team Explorer integration, build infrastructure, and all of the backend and pipeline of implementing these things. We had a lot of challenges right off the bat that we knew. These were things that we knew were going to be tough. First of all, we had to do 2 separate UIs. So you can see an example of these 2 separate UIs that we have. One is the Team Explorer homepage where we have our own UI. So the little section that says GitHub is our own, as well as some of the project buttons that you can see there. And this UI follows the Visual Studio theme. So the icons have to match the colors of the theme and the font colors, all of these things. Team Explorer gives us a class that we implement and interfaces that we implement and creates the UI for us. So we don't control most of this UI. We set properties and we control some things, but not a lot. And all of this is activated via callbacks and math. We don't control a lifetime of this UI. It just shows up whenever. So it has very specific lifetime constraints that we have to follow. Other UI that we have, like the login and the cloning and creating repos, are modal dialogues that we have that follow our GitHub desktop themes. So they are purposefully not following the Visual Studio theme. And there's YAML UIs with reactive UI and a bunch of other things. So completely separate UIs that we have to run side by side. Other problems that we knew right off the bat that could hurt us was footprint and performance, particularly in the Team Explorer areas. So we very early on established that we couldn't load certain things in the Team Explorer UI because that would bring in a bunch of dependencies that would always be loaded as soon as Team Explorer loaded, and that would be unacceptable in terms of memory footprint. But a lot of our code, if we wanted to do this in 4 months, we had to reuse a lot of code, and a lot of our code is reactive, and especially reactive UI, which meant that we actually had to split up the whole project in 2 areas. So we have 8 assemblies and 4x4, which match basically reactive and non-reactive code. So the non-reactive parts are mostly used in the Team Explorer areas, and then whenever we don't have these performance constraints, we can use other things that are in the reactive assemblies. That allowed us to, the split wasn't completely necessary as an assembly split, but it allowed us to not make mistakes when we were adding code, because if the reactive UI is not referenced or RxNet is not referenced, and you want to add something that uses that, you immediately, like, the project won't compile, and you'll know that you need to put those things in reactive or rewrite them. Other problems that are specific to the extension, because we're living inside Visual Studio, is testing. So we can do unit testing, and this is why we have a lot of interfaces to make sure that we can mock and test all of our things. But we are sitting inside Visual Studio. It's Visual Studio. To be able to test Visual Studio, our extension, we need to test the whole of Visual Studio. We need to automate everything, which is really, really, really hard. And we kind of opted not to do that because that would have been a whole another project to itself. So we make sure that every API that we use from Visual Studio has a layer in front of it, so we can mock those specific services and be able to test everything else that relies on those services without having to mock the whole of Visual Studio. Yet another challenge that we knew was coming up was installers. So the GitHub extension for Visual Studio ships as a part of the Visual Studio secondary installer, which meant that we needed an installer for it so we could be launched. But at the time, the secondary installer did not support v6 installers. It only supported MSI. So we actually had to build an MSI installer that launches the v6 for it. So we had to pick, I picked Wix because it's very easy to automate and script and build things. But unfortunately, MSI only supports 3 version parts, not 4, which meant suddenly our versioning system that we were so proud of and using Semver completely broke because MSI just ignores that part. That kind of limited the way that we actually did versioning in the project, and it still kind of affects it, even though we don't ship MSI anymore, because turns out the secondary installer now supports v6, and the MSI doesn't need to be there. But it still actually has had a long-term effect on, just because of this little detail. The way we version the extension now is different than the way we would version it if this constraint wasn't there. So those were the challenges that we knew right off the bat that we were going to hit. It was stuff that we knew. The things that we didn't know about was, as we worked on the code, the problems of running an extension in Visual Studio. Visual Studio is everything is loaded in one app domain, so it's any dependency that you load may potentially already be loaded in the process, so you might or might not get the dependency that you were expecting. And unfortunately, the runtime .NET only gives you the version of the assembly that you requested if it's signed. If it's not signed, it's not going to give you that version. It's going to give you whatever it's loaded in the system. So that would potentially mean anyone could break us by just loading before us and loading anything. Which means, and most of our dependencies are not signed, unfortunately, because signing is a controversial topic around the .NET community, which meant we had to fork every single dependency and sign every single dependency to make sure that what we requested was actually what got loaded and not something else that is in the process. The other interesting problem that I did not anticipate having was icons. At the time, the only documented way of loading icons and toolbars and context menus and other areas in Visual Studio was with image strips. I'm not a good artist, and loading these things and trying to make them look good on high resolution and high DPI monitors and make them scale well is just a pain. Fortunately, at the time, Visual Studio team had just introduced a new way of loading icons with XAML, so you can actually give a XAML icon. It will do whatever magic is appropriate to scale it to the DPI that Visual Studio is currently running on. So that was not too bad, but the documentation for that was horrible. But fortunately, we got that one solved. Other problems that we had were resource caching. For some reason, if you've done the LoopPF apps before, you'll know that you can put things in an app.xaml, a specially named file that will load global resources in a way that's shared across your app and at design time. Unfortunately, Visual Studio extensions don't actually have this. There's no Apple XAML file that can have global resources. So, and because there's no Apple XAML file, there's no way of giving Visual Studio design time resources so you can actually do work in design time on your extension. And there's no easy way to share resources because everything that you put in a XAML file will be loaded every time you load the XAML file. So that was actual very problematic because we're just wasting memory and loading and reloading everything every time. And design time is impossible. How do you design things if you can't see anything, right? So first solution, basic solution, is just having a shared dictionary XAML file that all the XAML pages load. So at least you can put, these are a place where you can put basic resources that are going to be shared. But that doesn't solve the problem of actually sharing them and having them being global. So the solution was to hijack the source property implementation of the resource dictionary manager, which there is a link there if you want to see that, to only load it once and then return the cached XAML that has already been processed to the resources that have already been loaded, which it's basically duplicating the work that normally AppXAML, which is special, would do for you. So that works fairly well. The shared dictionary files that we have on every single project that has XAML resources only get loaded once and get shared. But it doesn't really solve our design time problems, because turns out the XAML designer, if you override the source property, will immediately stop working. So yeah, that was annoying. We have solutions in place for that, but they're not pretty. Also had other problems like the Team Explorer loading our UI so early in the process that the directories where we would search for the DLLs where the resources are were not set in the app domain context, so are actually the assemblies couldn't be found, basically, which means things would break randomly because it was very heavily timing dependent. So interesting things that happened during the process. But all of these hurdles passed, and it's launch day, and we actually launched with all the features that we wanted, cloning and creating and authentication and logging in and all of these things. And we launched a build, and we were there and did a lot of demos, and people were very excited about this. And everybody else was there. There's a bunch of other vendors that also have extensions in Visual Studio, so we compared experiences. And we had a few crash reports on launch day, which are fun. And one of these was very interesting. So remember how I was very careful about forking and signing everything to make sure that nobody could break me if they introduced another version of an assembly that I happened to be depending on. Well, so as it happens, rx.net is signed. So that was one dependency that I didn't fork and sign. It's signed, so I'm using the doget package for it. Turns out that rx.net shipped, I'm not sure if it's true anymore, probably is, the same assembly twice. Two copies of the same assembly, basically. One built with .NET 4.0 and another built with .NET 4.5. They have the same version, the same signing keys. For all intents and purposes, for the runtime, they are exactly the same, but not. Unfortunately, the version with .NET 4.5 has extra methods, and the GitHub extension is a 4.5 .NET 4.5 profile. So it actually is depending on these extra methods. Xamarin happened to be loaded before us in the Visual Studio process because it's also an extension and it just happened to be loaded before. And they depend on the 4.0 version of rx.net because they need compatibility with previous versions of Visual Studio. Yeah. So if you had Xamarin installed for any reason and it loaded first, kablooey. Which meant I actually now ship with a fork, a differently signed rx.net version, just to make sure nobody can break me. Another interesting thing that we had was ReSharper. So during builds, there's some reports that it was very slow to type in the login dialog, but only when ReSharper is loaded. And we went back and forth on this, trying to figure it out. And it was suggested there might be threading issues because ReSharper hooks into every single window, independently of whether it's actually a ReSharper window or not. But why would there be threading issues? So it turns out that there's a piece of code that I'm using, even though from another library, Reactive UI, and the piece of code had this, which is basically detecting whether we are in unit test mode by scanning the list of assemblies that are loaded in the process and determining whether that means that we are in unit test mode. Of course, it's Visual Studio. Everything is loaded. That means we were always running in unit test mode. So reactive UI was basically disabling all of the threading code all the time. And it didn't really, we didn't really see it until ReSharper came in, and both of them together kind of screwed them over, basically. So that was fun. Turns out it's assumptions. This reactive UI code was made, the assumption that's running on a standalone app that controls its own dependencies, and we're running inside Visual Studio, which doesn't control, we don't control the what's loaded in the process. So all of these bumps and hurdles succeeded, and we shipped a few more versions to fix all of this stuff. And then we went into open sourcing. So on July 20, 2015, we did a release called Freedom Prize, where it was the release with very little changes to the previous release, just open sourcing the extension. So it took us a while from the April 30 release to get the extension open source, because once we were done, I actually had to go through everything, clean up issues, create a new repository. So the process includes creating a new repository, migrating all of the relevant issues. Some of the issues that we had were private conversations about internal features of Visual Studio that are confidential and can't be migrated, and other team discussions that weren't meaningful. So only the issues that were actually relevant to the project itself got migrated. And then, of course, there's always a bunch of things that leak, private keys, private IDs. Even though we're very careful about making sure nothing got leaked, there's always some things. But I didn't want to lose the history of the project, because the history of the project is the documentation. And if people want to contribute, just dumping code and going like, here's the code, is not productive, because there's no reasoning of why the code exists. So all of the history of the project was important, but we had to clean it up to make sure that nothing that shouldn't go out went out. And this also included making sure that we weren't accessing any private internal APIs that we shouldn't, because that code is also a role model for how to access certain Visual Studio APIs. So it would be nice to not give the wrong examples. So for all of these reasons, I went through and created a new repo, importing all the history, but filtering out all the stuff, commits and data inside it that weren't useful. And with a private submodule where we keep the actual private bits like client IDs, app secrets, and all of these things, so that anyone can build a GitHub extension for Visual Studio, and they can configure it with their own client app and client ID, which is whatever they want. And when we build it in our CIs, the build gets configured with our configurations. But being open source is more than just putting the code out there. There's a process for this, and if we're going to open source and actually have contributors in, we have to have documentation, and we have to have guidelines and all of this stuff. We have a process for this, and we have an amazing open source team at GitHub that takes care of making sure that if we want to open source anything, that there's guidelines. So we had to create contributor guidelines, documentation, and make sure people can build, because it's very easy for us to just have internal builds and forget that people that don't have access to internal bits can't build them. We have to make sure that we have code conventions. We needed to decide on a license, and all of these things that are important to making sure that it's an actual open source project and not just a code dump. And again, migrating history is essential for this process. We also have the problem of balancing contributors once we are open source. how do we maintain the quality of the product because it's branded with the GitHub brand. So we want to maintain a certain quality, and we also want external contributors to contribute, and we don't want to have the barrier of entry to be too high because otherwise nobody will contribute and it's kind of pointless. So this is an application instead of a library. Libraries are easier to manage in that the API is their UI, is their UX. They're meant for developers. It's just an API. It's a library. An application has other concerns. There's design, there's UX, there's UI, there's branding, there's colors and themes, and all of these things. There's workflows for users, and all of these things are important to make sure that what goes out is good, which means getting contributions from contributors go through all of this process, which might be frustrating for people that just want to, ship a very quick feature. We also have concerns of making sure we never crash, because if you crash, we crash Visual Studio, and then people will scream at us, and that's bad. So never, ever, ever, ever crashing, which means code reviews are stupidly important, and we're making sure that everything is logged and appropriate. All of this means it's very hard to accept contributions, but we've had amazing contributions from external developers that have, particularly the GIST support, which took a long time to get in, but it is a pure external contribution. So these are the ongoing problems that we have as we try to do an extension for Visual Studio in a community that is not very big. It's a very niche area of development. But on the other hand, it's very important because we really want to give developers really good tools. And we really want contributors. So this is the ongoing problems that we have while maintaining the open source project, beyond just, the regular bugs and crashes and all of these things that happen, and making sure that we have new features. And always contributors welcome. I guess I went through this a bit too fast. I thought I would take more time on it. And I actually cut a bit of a bug that I wanted to talk about because I was afraid I was going to be a bit longer than this.
Well, that's fine.
Let's
go back and see it.
Questions?
Well, we can also go back and see
yes.
it. I'm right here, and you can switch back to your IDE and talk about the bug.
Oh, yes. So the bug, I actually have the slides for this. I just hit them.
All right, let's do it.
So this amazing thing that some of you might be aware of, some of you might not. Around September or October, I think, we had a little bug that I called the $600 bug, because I can never remember it's 6,500. This all happened when I was sleeping, because it was midnight. It was from midnight to 5 in the morning in Copenhagen. And this is basically the proof of multiple, the problem of having dependencies where you don't know what the code is doing exactly, because there's a lot of dependencies, but also the advantages of a remote team. If you can read the news report. There's a pretty good news report about this. A developer in South Africa pushed an AWS key into his repo and then published the repo with the private checkbox on the extension, and then went to bed. Next morning he wakes up and there's a $6,500 bill, because the repo that he thought was private was actually public, and there's bots going around on GitHub collecting AWS keys and using them to fire off Amazon instances to do whatever they do. So basically he had this bill. Apparently it's a thing that happens a lot. So he reported the bug to us, and the bug report came around midnight. I didn't see it. I was asleep. But the other members of the desktop team saw it, because we have people all over the world. Phil is in Seattle and Brendan is in Australia. So it's a really good thing to have a remote team that can cover all the bases. And basically it was a very subtle bug that was interacting with property changed events, and because of a theme that I did a month before. It ridiculously ridiculously subtle. The change was completely innocuous. There was no reason to think that it would completely break the behavior. And visually, it looked like it was checked the checkbox, but it wasn't. The property never got fired. They never got listened to, so it never got set. So it was a general failure in manual QA, because it's one of those things that you have to actually manually test, because it's a UI specific problem. And in general, just horrible. You wake up with a $6,000 bug, it's a problem.
So can I ask you a couple questions?
Yeah.
Okay, so I want to understand, it was a checkbox control, like a composite control? It was a control of controls?
Yes. So the original checkbox was just a checkbox, but Team Explorer has a slightly different style. And that checkbox, just normal Visual Studio themed checkbox, didn't match the Team Explorer style. So me and my complete ignorance of consequences changed the checkbox to have two checkboxes, one inside the other. So one of them rendered the check, but the other one actually activated grabbed the event, the mouse event. Unfortunately, the way it would work if it was just XAML bindings, but unfortunately Reactive UI, it was bound by Reactive UI at the time and not direct XAML bindings. And Reactive UI only looks for the property change event of the outer box, doesn't look for rooted events coming in from the inner box. So basically everything worked, but it didn't. It was just the multiple things working together.
Was that your bug? Because you nested the checkboxes, yes. Or was it Reactive UI's for not listening correctly? Shouldn't it have listened to routed event?
It is the assumptions of me. It's the assumptions of code, right? The Reactive UI is assuming X. If you follow all of whatever guidelines that you need to follow for this X to work. And I didn't know about this particular assumption. It's a very subtle assumption.
Right.
As long as you always bind with certain Reactive UI code behind code, it would be fine.
Right.
Or it's all of the assumptions of how dependencies work, basically.
Right.
Which I didn't know.
And wouldn't you say that brings up, outside of .NET and outside of GitHub for Visual Studio, kind of a larger philosophical question, which is, like, assert your assumptions in software engineering. At any time, if you are assuming something, if there's some way you could assert it, so then you pointed out it's difficult to test UI stuff. You know, the web has Selenium, there's all sorts of UI tests. There's some UI testing in Visual Studio. What did you do afterwards to put in a safety net to prevent this? Did you add more manual testing, or did you put in some assertions somewhere about the state of the system?
Put in documentation and knowledge so people know how this is supposed to work. Put in manual testing. We have a test manifest that we go through every time we do a release. Beyond the unit tests that we do.
Right.
And the one where checked that private is actually private, and actually just check that all of the UI will produce data that corresponds to what the UI is showing.
Right. So assert the assumptions of all of the state from the UI all the way down to the backing state.
Yes.
Interesting. What happened to the developer? Did he get a refund?
Yeah, he did. It's the thing that happens. Amazon is very aware of it, and he got a refund, and he acknowledged that you should never commit an AWS key on your repo, regardless of whether you're pushing it public or privately. And we didn't have that many problems besides this particular repo. Other people wrongly pushing public things. What we actually did is immediately after pushing a fix, which was at 5 in the morning when we were still asleep, one of our team members made it so that you could not call the GitHub API with a version of the extension less than the new release. So if you have an older version, you won't be able to call the API.
Right.
To make sure that people that don't upgrade don't actually fall into this trap.
One of the other questions that I had early on, you were talking about some of the issues around loading yourself into memory. And I think that it seems like when you're writing a DLL that runs in someone else's process, whether it be loaded via MEF or loaded via assembly.load, you're really kind of at the mercy of that process. And I'm always hearing about all sorts of problems around the life cycle of that loading. Like, when exactly did you get loaded? What is the state of Visual Studio at that moment? And you had a thing that you were talking about around the state of Solution Explorer.
The state of Team Explorer.
Team Explorer.
Probably.
Yeah, there you go. You were there. Team Explorer loads so early.
Oh, yes. So, yes. Yeah. So, usually when you, in this case, it's definitely that. You don't know when you're getting loaded. You have no idea what the context is. So you just have to go with it.
Right.
In this case, it might actually be a bug that still exists, but it's also a timing problem with loading UI that you have a XAML with code behind, and when Visual Studio initializes the XAML and tries to load things that are dependencies of that XAML, other things like or other resource dictionaries that you might be having on that XAML, the list of directories that it scans does not include the extension directory itself. For some reason, at that point, Visual Studio is still initializing, or Team Explorer is still initializing, and even though the extension is already loaded, it is not yet set into the app-domain context loading directories, which means letting the XAML any dependency would fail. It would be able to load everything within that assembly, but any other dependent assemblies would completely fail. And that one had to be solved by hooking up into the runtime, the app-domain assembly loader, and actually adding the directory of the assembly. Because we're running the code, we know where we are.
I see. So you had to make your own assembly loader and basically say, yes, I need this directory in there.
Yes, if you're loading this type, we're here.
But when you're doing that, aren't you potentially hurting? Could you not mess up other assumptions being made of other assemblies that are being loaded by other extensions?
No, we actually, yeah, this probably doesn't work. We only do this for our own assemblies because of that.
Oh,
it's not like,
okay. So you went and you have a shared dictionary manager. You didn't just say arbitrarily, yeah, let's add this directory wholesale. You said, let's add this directory and these 8 or 9.
Yeah,
okay.
It's basically when the assembly resolve tries to load a DLL that it can't find, which in this case it's all of these. We go like, oh, it's one of ours. Here, I'll load it for you. Here it is. And as soon as I do that, things work.
But isn't this an example of the abstraction, the lovely abstraction that's provided to us by MEF, now completely leaking, and now you're down in assembly with an assembly resolver?
It's more of, actually, I think it's more of it wouldn't even be with MEF, because this will happen with any XAML, even if it's not MEF. It's dependencies that are linked in XAML. It's more the problem of the plugin model.
The plugin model of Visual Studio itself?
Or a plugin model in general.
Oh, plugin models as concepts. Okay.
As a concept, right? You just say, oh, load me into the process. And you're doing this not at startup, but at any point, right? Load me into the process. So the thing has to load you in and then configure everything else to make sure that you can be loaded and all the contexts are set, right? There's a lot of opportunities for failure during this. And this one is one of those where it might be a bug, it might be a race condition, I don't know, but it happens.
So to be clear, so for the audience, you are running in devenv.exe, correct?
Yes, this is
entirely in process, and Visual Studio itself is a shell filled with other plugins. So is your plugin a peer to like Team Explorer? That's a plugin of sorts, right? And
yeah.
You know, the ASP.NET Web Tools, that's a plugin. So you've got all of these plugins all loading, some synchronously, some asynchronously, all competing with each other.
Yeah.
But you're using the same APIs that Microsoft uses, right? So you are a first-class peer plugin, and you are integrated fully into Visual Studio like anything else.
Yeah, exactly. I mean, if you go into the MEF catalog, you have like 2,000 things that you can possibly instantiate just with nothing loaded, with just Visual Studio. There's like 2,000 different
Potential things.
services providers and things that are potentially that you can instantiate just off the bat, and that's just the stuff that gets exported via MEF, because extensions can or might not be MEF. The entry point for an extension is actually a package, so it's a thing that you don't have to use MEF for a lot of things. So there potentially, if you scan the app domain for all the assemblies that it has loaded, it's ridiculous. It has everything loaded.
Yeah. Do you think that, as someone who's now worked in the plugin space for some time, that there would be a benefit of having the certain kinds of plugins be out of process? Like there's been I feel like we oscillate as a community towards putting everything in process versus breaking things up into processes that then do inter-process communication.
It would be beneficial for some type of work that you really want to do on the side, that you don't want it to interfere with everything, because everything, I mean, there's one line in one of the slides that I said, don't export iService provider.
Okay.
Because if I export iService provider, I'm going to break everything that imports iService provider.
Right.
It's just a thing that is, right? If you do it out of process, you certainly, I mean, even like on a separate app domain context or something like that, where things don't interfere with each other, that will certainly alleviate some of the problems. But a lot of the power in Visual Studio, a lot of the extensibility that it has comes from this ability to just load everything. So it's a hard choice.
Yeah, and it seems very interesting when you think about other kinds of IDEs and how they do stuff, and also IDEs that are not all written in C# or written in .NET, like Visual Studio. Like Visual Studio Code does things out of process for kind of necessity, and for compartmentalization, and also the difference between Windows processes and Linux processes, and the relative heaviness and weight of those things.
Yeah, it's a very complicated thing. And the problem is when you have the architecture already built, changing it to introduce other type of process models for these things is hard.
Yeah.
Because especially with the compatibility assumptions of Visual Studio, you can run extensions that have been made 5, 6, 8 years ago, and they will still run because all of the APIs are there. You're just building on top of it. This has a lot of costs. A lot of these problems come from that cost of maintaining compatibility across years and releases, right?
Yeah, that is one of the things that I have learned as an employee of Microsoft, is that from the outside it's really easy to say, oh yeah, you just break that, that's stupid. And from the inside it's like, oh wow, you don't think about the scale. And like as GitHub, you're working at a big company, and if you go and say, yeah, we're going to break that, and that API then breaks for not 1,000 people, but maybe 50,000 or 200,000 people. Like that's enough people that will be calling you on the phone at 2 in the morning, upset that then you maintain compatibility, and it goes on for years.
Well, we are consumers of the GitHub API. So if the API team wants to break an API, it will break us as well.
Yeah.
Because we can't guarantee that our users are going to update instantly. Because they can't, because the extension has admin privileges because of the installers. There's a lot of stuff that goes into actually being able to update things. So people are not at the bleeding edge. They will be at the bleeding edge when they update.
Right.
So if an API suddenly breaks on us from one day to the other, even internally at GitHub,
right,
that is going to affect everybody that uses the extension, right?
Yeah.
So it's not even just clients or users, external users of GitHub, it's us. Like everybody has this problem.
Right.
Compatibility is important.
Yeah. We did have a couple of questions. One question from Ian Barker just was an important feature question. This is the GitHub extension for Visual Studio, not the Git extension. So this is not for Bitbucket Git repos or your own local Git repo.
This is really important because we're so integrated into Visual Studio that it's very hard to tell the difference between one and the other. Visual Studio ships with Git support. So commit, push, pull, sync, fetch, basic Git support. We add authentication to GitHub, 2FA supports, and credential management, and then GitHub specific features on top of that. So pull requests, just issues, all of the things that are on top of Git that we as GitHub provide.
Right.
And we have a ton of people that go like, oh, but commit is not working. It's like, it's very hard for people to understand the difference.
Right, right. Okay.
So yes, that's a important question.
But like, for example, I, as a GitHub user, when I switched to two-factor auth, I started having all sorts of confusion and trouble around what exactly am I supposed to use at the command line, and does this GitHub or Git, when I do my push, is it going to understand two-factor auth? Do you hide all of that for me? Do you pop a dialog
Yes.
and I do two-factor and I don't have to think about it? Because I've always found that credential management, when I went to two-factor, became frustrating.
Yes, that was actually like goal number one, was to fix that. So if you have the GitHub extension, you log in, do your 2FA or not, depending on how your account is set up. Credentials will be stored in the Windows Credential Manager safely, and Visual Studio use those to do Git operations. So as soon as you're logged in, you don't have to worry about it anymore. It just works.
Very cool. That's great. Well, thanks so much for talking with us today. We
Thank you.
appreciate your time. Hopefully you're not up too late over there. I guess it's dinner time. Right?
No, it's 6:50 and the sun is not going to go down until like 11, so it's fine.
Oh, I forgot. You do have the eternal sun
Yes.
over there. Very cool. Well, thanks for joining us for dotnetConf, and we'll see you again. And folks can, of course, follow you on Twitter and check out your
Yes.
GitHub repository.
Yes, do that and contribute code.
Yep. And actually, a little bit later today, we're going to have Jasmine from GitHub talking about OctaKit, which would be kind of deeper down in the stack and how and one of the things that you call as a consumer of the GitHub
Yes.
APIs.
Yes, we're very dependent on that, and we love it.
All right. Very cool. We're going to take a little bit of a break, and we'll be right back for dotnetConf. Bye, everybody.